Algebra 2. This is Unit 10, Lesson 3, and today we're going to talk about creating polynomial equations. So what we looked at so far is that if you have the roots or the solutions, so these are going to be my roots right here, R1, R2, R3 are my roots, then I can sort of work backwards to find the factors and then eventually multiply those factors and I can find the equation of that polynomial function. So if the roots are R1, R2, R3, then the factors would have been x minus R1, x minus R2, and x minus R3. The polynomial then would be y equals a, x minus R1, x minus R2, and x minus R3. So the only thing we didn't talk about so far is a. What is a? A is some constant that is going to be determined by another point. So in addition to the roots, I have to give you another point. Let's see how this looks. So in exercise 1, I want to determine the equation of a quadratic whose roots are negative 3 and 4, and which passes through the point 2, negative 5. So my roots are negative 3 and 4. All right. So that makes my factors x plus 3 and x minus 4. So y equals a, x plus 3, x minus 4. So all I'm going to do is I'm going to plug in the point for x and y and solve for a. So my point was 2, negative 5. So I'm going to take that exact equation that I have, but I'm going to plug in negative 5 for y. So negative 5 for y, and I'm going to plug in 2 for x. So negative 5 equals a, this is 5, this is negative 2, so negative 5 equals negative 10a, divide by negative 10, a equals 1/2. And now that I know that a is 1/2, I can write my equation. Y equals a, which is 1/2, x plus 3, x minus 4. And then if I FOILed that, I get y equals 1/2, and that's going to be x squared minus 4x plus 3x is a negative 1x. And then I can just distribute that 1/2. And that is my equation. Okay, so just by knowing the roots and another point, I can write the equation. What will that look like? Well, it's a quadratic, so that is an even power. Even powers are both going to go in the same direction. Okay, so it's going to go, both are going to go up like that. So my roots are negative 3 and 4. Those are my solutions. So it looks something like this. There we go. Okay, and I know that it's facing up because a was positive 1/2. All right, so not too bad. Let's look at exercise 2. On exercise 2, we're going to see how the value of a actually affects the graph. All right, so if we're looking at the quadratic y equals a, x plus 2, parentheses x minus 5, I want to know the x-intercepts. So the x-intercepts are the roots, the solutions. So x equals negative 2 and x equals 5. Negative 2, 1, 2, 3, 4, 5. Okay, and my graph would look something like this. All right. And let's try, so I can plug all three of these into my graphing calculator. So that's the first one. Now what happens if I change that a? Let me do it in a different color. If a is 2, okay, I'm still going to have the exact same roots, but this is going to get narrower. All right, so the 2 and the 4 are going to make your graph get narrower. It's going to be a vertical stretch, but they still have the same exact, oops, that is awful looking, sorry about that. It's just hard to write on the iPad like that. So, but it's going to be narrow. It's a vertical stretch. So this is going to be a vertical stretch. It is not moving it left, right. They still have the same roots, the same solutions. And if I had y equals 4, that would make it even narrower. And I probably didn't make the first one wide enough, so then this one is going to be even narrower than that one. And the red one should have been a little bit wider. I should have started with the first one wider, and then it would have been easier to do. All right, but important thing is the A does not change the zeros, but it does stretch it vertically. All right, let's look at exercise 3. Create the equation of the cubic in standard form that has x-intercepts of -3, 1, and 7. All right, this is a cubic. It's also going to be positive, so it's positive and odd. So that means it's going to be like this. Okay, positive and odd. To the left it goes down, to the right it goes up. Let's write my equation. Y equals A, so this is going to be x plus 3, x minus 1, x minus 7. And now I'm going to plug in the point -2, 54. So 54 equals A, -2 plus 3, -2 minus 1, and -2 minus 7. So this is 54 equals A times 1 times -3 times -9. So 54 equals 27A. So A equals 2. All right, now that I have that, I can write my equation. Y equals 2, x plus 3, x minus 1, x minus 7. All right, so let's put points at each of these. So I got -3, 1, and 7. 1, 2, 3, 4, 5, 6, 7. All right, we know it goes down on this side, and we know it goes up on this side. There we go. And all of these have a multiplicity of 1, so they're going through the x-axis. Remember, if it had an even multiplicity, then it sort of just touches and bounces off. Right, but that is our equation, and that is our graph. If you put that in the graphing calculator, it should look similar. All right, I'm going to skip 4, but let's look at 5. Let's create the equation of a cubic. So again, a cubic in standard form that has a double zero at -2 and another 0 at 4. All right, so x equals -2 is a solution, x equals 4 is a solution. So y equals A. Now, it has a double zero at -2, so I'm going to have two factors that are going to be x plus 2, and I'm going to have one factor that's x minus 4. All right. It has a y-intercept of 16, so my point is that I always need another point to find that A. My point is going to be 0, 16, so I'm going to plug in 16 for y, and I'm going to plug in 0 for x. All right, so that's 16. So that's A times 2 times 2 times -4. 16 equals -16A. So A equals -1. All right, so this is a cubic. So it is odd, but it's also odd and negative. Odd and negative when we're talking about the end behavior goes up on this side and down on this side. So -2 is a root, and 1, 2, 3, 4 is a root. Now remember the multiplicity. So if it's an even multiplicity, then it just touches. So at -2, it's going to just touch and bounce right back up. And it's going through here at 16 because they told me I had a y-intercept of 16. It might still keep on going up a little bit, and then it goes through. All right, so this is an odd multiplicity. That's why it goes through at 4, and this is an even multiplicity at -2, so it touches and goes back. So number 6, they wanted to describe that, so it's exactly what I just said. At the double root of x equals -2, graph is tangent to x-axis. That means it touches x-axis and bounces off. sorry, bounces. It does not cross. All right, and let's write the equation of this. So I have y equals, a was -1, x plus 2 squared, and x minus 4, because it had a double root right there. Okay, and does it ask me to multiply that out? I certainly can. Create the equation. Yeah, it does ask me to create the equation. So this is the equation. If you wanted to see what that was, if I multiply that out, I have x plus 2 is happening twice. So I'd have to do FOIL twice. So this is going to give me, these two are going to give me x squared minus 2x minus 8. And then I'm going to multiply all of that by x plus 2. So that's going to be x cubed minus 2x squared minus 8x plus 2x squared minus 4x minus 16. I'll combine all those like terms together and gives x cubed minus 12x minus 16. But then don't forget that a was -1, so I would have to distribute that. So y equals -x cubed plus 12x plus 16. Okay, so just keep on adding on. Each thing that we're learning will get us closer and closer to graphing more accurately and also being able to write equations.